Hello, my dear students. Good morning, all. How are you? Okay, I think you are fine. So, welcome to our Sarva Siksha Abhiyan online classes. Okay, myself, B. Radha Devi, working as a physical science teacher at KGBV, Kallur. So, in the previous classes, you learned about the refraction of light at plane surfaces. I think you have an idea about that concept. But today we are going to discuss about the next topic, refraction of light at curved surfaces. And it is very interesting topic to you. You can easily understand very well. Okay, so dear students, did you remember a very famous rhyme in our childhood that is Twinkle twinkle little star, how I wonder what you are. This is the rhyme in your childhood you have learned very well, I think. So I'm asking question to you, is the stars really twinkle? No, because you got an idea about the refraction of light in the previous class itself. So here the stars are not twinkle really. Now, what is the optical phenomena behind the twinkling of the stars? What is the reason behind it? Why they are twinkling? To know that one, we have to find the refraction of light. Okay, so just recall the previous concept, that is refraction of light at plane surfaces. Okay, students. Now, here you have a broken pencil image. Okay, it is a broken pencil image. See here, if you observe that, you can see the pencil appears to be broken at the surface of the water. Why? What could be the reason? Yes, again the reason is the same reason, is refraction of light. So, dear students, so far we have learned the refraction of light only across plane surface. Let us recapitulate what we have learned in our earlier classes related to the refraction of light at plane surface. Okay, students? Okay. Now, if you observe the ray, means the light ray which is coming from a homogeneous medium, means in a plane surface. See here, the ray is coming without any deviation because it is a plane surface. It is only one medium. So here, ray of light through homogeneous medium, how it passes means a light ray passes in a straight line provided there is no change of medium. When the light ray passes in a straight line, because when there is no change in medium, at that time only the light ray travels in a straight line. Okay, students, if the light ray traveling in a straight line means it doesn't have any change in medium. Okay. Now I am asking question to you, what are transparent materials? We have so many transparent materials around us. So let us learn about transparent materials. The objects which allows the light to pass through them is called transparent materials. Means when the light ray is coming from the surface of the air, means from the air, it reaches the surface of the materials, and again it releases the light ray in the other side. Okay students, for example, we have so many examples like glass. When we torch the light ray onto the glass, that time the light ray passes outside the glass, inside the glass, and it will send outside the glass also again. Like that lens is there, clear plastics, diamond, clear cellophane sheets, water, air. These are the best examples for transparent materials. Okay students. So transparent materials means which allows the light to pass through them. Through them means inside also. Okay. Now if the light ray travels from one transparent material to another transparent material, then at that time what will happening? We have to find it. So what happens when the light passes from one transparent material, means from air to glass? You can take the example. If the light ray travels from air to glass, at that time what will happening? So to this one we have to see an interesting activity. So let us see with an interesting activity. Okay students. So here this is the activity to you. You can watch it carefully. Take a transparent glass and fill it with water and dip some portion of pencil vertically inside. Okay, and observe. And keep the pencil inclined to water surface and observe. Now what do you observe? So in the first case the pencil is in the pencil is in a straight way. Here the light ray is traveling parallel, means parallel to the pencil direction only. Okay, but in the second case, see, here the pencil is bending, means we are keeping the pencil in an inclined way. So you can observe the both pictures. Okay students, so what is happening, what you are observing in these two diagrams? Let us see. Okay, so for the first case, in the normal incidence, when we are keeping the pencil in a straight direction, at that time we have two mediums, that is air means rarer medium, and in water means denser medium. When you are keeping the pencil in a straight way, at that time what is happening means the refracted ray which is entering into the denser medium, at that time it doesn't going to deviate, because here we are not creating the angles. Okay students, so it is not going to deviate, means it is not going to bend. So here the ray travels without any deviation, means the refracted ray travels without any deviation because it is traveling in a straight way. Okay, so here the angle of incidence I is equal to 0, as well as R means refracted ray of incidence is also 0. Angle of incidence I equal to 0, angle of refraction is equal to 0. This is the first case. And when you coming to the next second case, here when the pencil is going to kept in an inclined way, at that time what is happening, we will see with the ray diagrams. Okay students. Okay, so here two mediums are there, rarer and denser mediums. So rarer medium is taken as N1 and denser medium is taken as N2. Okay, so here when the light ray is traveling in an inclined manner, here see, you can see here the light ray is coming in an inclined manner. So I have taken a normal line, I have drawn a normal line, and the angle of incidence here taken as I. Okay, then next, what will be the uh, traveling way of the refracted ray? Okay, it is going away from the normal or towards the normal. Already we have discussed this topic in the refraction of light at plane surfaces. So the ray of light is going towards the normal. Okay students, very good. So the refracted ray is going towards the normal. So here the angle of refraction is R. Here the Snell's law is also applicable. Here angle of incidence I and angle of refraction R are not equal. Okay students, so hence Snell's law is going to be applicable here. So here what is Snell's law? N1 sin I is equal to N2 sin R. Okay, next, so this is all about refraction of light at plane surfaces. So now we have to find here what is refraction actually. What is refraction? See, when light travels from one transparent medium to another transparent medium, its direction changes at the interface. So when the light ray is traveling from a transparent medium air to another transparent medium glass, at that time the direction changes. Where? At the interface. I will show the interface where, means I will show it in the next videos. Okay, next slides. So this is the refraction. These are all about refraction of light at plane surfaces. Just we have to take as recapitulation. Okay, see here you can see the broken spoon also. This is the refraction, because here the light ray is going to transfer from transparent medium air to glass here, like so that we can watch the broken spoon image. Okay, so if you observe the images, for example I have taken some images, you can observe that what is this image? This is the paper weight. Okay, so if you pass the any light ray, see here we get different types of colors. Okay, oh wow, this is a droplet which is on the surface of the leaf. See here how it is refracting. Curved surfaces, mirrors, lenses, already we have got an idea about this in our lab also. Binoculars, lenses means spectacles, magnifying lens. Now what is the common feature among all these images? Yes, they are transparent. Are they plane surfaces? No, they are curved surfaces. So today we are going to discuss about the refraction of light at curved surfaces. So today we are going to learn how the refraction of light taking place at curved surfaces. So let us watch an activity, a beautiful interesting activity. Okay, are you ready? Okay, so we are going to learn the refraction of light at curved surfaces. Okay students, take a piece of paper and draw two arrows in the same direction. Okay, and take an empty glass tumbler and keep it in front of arrows. You can observe the diminished image of the arrows, then try to pour some water into the glass tumbler. Observe it carefully. Wow, the lower arrow gets inverted. What could be the reason? If you see through air, the two arrows are in same direction. Whereas if you observe through the glass, the lower one gets inverted its direction. Why? Yes, I will explain you. Okay. So, what is happening means, from the previous activity, can you tell what is the reason for the inversion of arrow direction? Can you guess it? Yes, you can get the answer after the discussion of refraction of light at curved surfaces. Why it is happening, you can get at the last of this video. Okay students, so before going to learn refraction of light at curved surfaces, let us try to introduce what is actually the curved surface to a light ray. Okay, we will see this one here. Curved refracting surface. What is curved refracting surface? See, here I have taken a paperweight which is made up of glass. Okay, see here I have kept it in a air, means in the place. Here we have air and glass. So paperweight is made up of glass and have kept it in air. Okay students. Okay, see here, when the light ray is traveling to hit the outer surface of the sphere, okay, outer surface of the sphere, that portion of the sphere is called as interface. So here the light ray is traveling to hit the outer surface of the sphere. So where the light ray is entering into the paperweight, means glass medium, so here it is in curved shape. If you observe it, I have drawn in a yellow color sketch. So this is called interface. Okay students, so this one is called intersurface, that is curved refracting surface. Okay, now we are going to learn about the terms which are coming to you to help you to draw the ray diagrams. Okay students, now first one is center of curvature. What is that? Center of curvature. So here center of curvature means, here I have taken a sphere shape image object. I have kept center for this sphere, and this center is called as center of curvature. Okay students, so what is the definition? The center of the sphere of which curved surface is a part is called a center of curvature. See, around the center I have kept, around the sphere I have kept a point, that is called center. This one is called center of curvature. Okay, next term is pole. So pole means, see, so where the light ray hit the interface, first hit the interface, that one is called pole. Okay, the center of the curved surface is called the pole, curved surface, not a sphere. Here sphere is different for pole. See here, for center we have taken it as middle, but in the case of pole we have taken it as curved surface area, interface, that is called, in center we call it as pole, and it is also called as optic center of the surface, optic center as the surface. So pole means it is the center of curved surface, we can call it as optic center. Okay students, next, principal axis. What is principal axis? See, here the light ray is traveling along with the pole and center of curvature. This is nothing but principal axis. See here, the line which joins the center of curvature and a pole is called principal axis, which joins the pole and center of curvature. That line is called as principal axis. Okay students, now see here how to draw a normal to the curved surfaces. Okay, we can draw so many normals, okay, by using center. See here, I have taken a circle and I have drawn pole, center of curvature, principal axis line, and from the center itself we have taken we can took so many normals. We can draw so many normals with the center. See, I have these two figures. In the first figure I have taken two normals, but in the second figure I have drawn so many normals. So like this you can draw so many normals with the center. But every normal line should pass us from the center to the point on the curved surface only. So every normal line should be drawn from the center itself. Okay, and it has to be on the curved surface only. Okay students, so normal incidence means this already we have drawn the ray diagrams for the reflecting of surfaces in a plane and curved surfaces. Now here how you can draw the ray diagrams by using the refraction of light at curved surfaces. Okay students, let us watch. See here, a normal incidence means the light ray is traveling along with the principal axis and another light ray is traveling along with the center. Okay, here any deviation is there. So according to Snell's law, the ray which travels along the normal drawn to the surface does not deviate from its path. Hence, both rays are not deviate. They are travel along the normal. Here the light ray is traveling in the straight way. Okay, this is the normal incidence. So what happens when the light ray travel to the principal axis? Travel parallel to the principal axis. So let us see with some pictures. Okay, here I have taken a convex refracting surface. Okay students, so convex refracting surface. So when the light ray traveling parallel to principal axis, where in the convex refracting surface, keep it in mind. Okay, so when the light ray is traveling parallel to the principal axis, what is happening? If you observe in the picture here, the light ray is traveling from rarer medium to denser medium. How it is traveling? It is traveling parallel to principal axis. Okay students, it is traveling parallel to principal axis. So when the light ray is traveling from a rarer medium means air, so at that time we have taken as a normal from the center. Okay, then according to Snell's law, the ray which travels parallel to the principal axis, that one from rarer medium to denser medium, it is going towards the normal. So a ray traveling parallel to the principal axis strikes a convex surface and passes from a rarer medium to denser medium. Then at that time it passes towards the normal. Okay students, here the Snell's law is applicable. See, This is the first case. And in the next case, when you taken as concave refracting surface and the ray traveling parallel to the principal axis, then what is happening? Let us watch the ray diagram. So when the light ray is traveling from concave refracting surface, so the light ray is traveling from denser medium to rarer medium. Okay students, from denser medium to rarer medium. So when the light ray is traveling from denser medium to rarer medium, at that time see what is happening means, here the light ray is traveling from denser, then if you draw a normal to that ray, see here the refracted ray is going to away from the normal, so here the refracted ray is away from the normal, so the ray bends away from the normal. Okay students, in the next convex refracting surface, ray traveling parallel to principal axis. So let us watch the ray diagram. So when the ray traveling to parallel to principal axis, see here the light ray, when the light ray is entered from denser medium to rarer medium, at that time also the refracted ray is away from the normal. The refracted ray is away from the normal, they are not going to meet at anywhere. Okay, their extended rays also are not going to meet. So here the refracted ray bends away from the normal. Okay, and in the next case, concave refracting surface. So ray traveling parallel to principal axis. What is happening when the light ray travel in a concave refracting surface? So let us watch the diagram. So here for the concave refracting surface, when the light ray travels from rarer medium to denser medium, okay, see here the light ray is traveling from rarer medium, and if you draw the normal, and you can extend the normal, then at that time the refracted ray is towards the normal. Okay students, so what you understand? So in all these four pictures, the light ray is going to incident parallel to the principal axis and is going to meet the principal axis at one point. The refracted light ray, where it is going to meet the principal axis, that point is called as focal point. Means where the light ray is meeting at the principal axis by extending it also. So at that point is called as focal point. So what is focal point means? The point where refracted ray intersects the principal axis is called focal point. Okay, so where the refracted ray intersects the principal axis, it is called a focal point. Okay children. Okay, so children, many times you might have seen the image of a lemon inside a glass. Okay, if you observe that one, have you ever wondered when the lemon appears to be bulge inside when you are observing through water as well as glass? See how the beauty of the image through a curved surface. Okay. Now, formation of image at curved surface. How the image has been forming at a curved surface. Now we can get an idea about these by the ray diagrams. Okay, students. See here. This is the ray diagram. You see here, when we taken a curved surface from and kept the terms, means center of curvature, pole, and if you are drawn a light ray at the point O, means object, again draw the light ray, another light ray, then see, if you draw the normal to the two rays, then here angle of incidence is I and angle of refraction is R. Two refractive indices, one is air and another is glass, that is N1 and N2. And from image distance, from P to O, the image distance is U, and from P to I, the image distance is I. Like this we can draw the ray diagrams to get the image at curved surfaces. Okay, students. So, curved surface formula. Already you have learned mirror formula, lens formula in the previous lessons. So, here you are going to learn about the curved surface formula. So, what is that? Means N2 by V minus N1 by U is equal to N2 minus N1 by R. Okay, students. So, what is the curved surface formula? N2 by V minus N1 by U is equal to N2 minus N1 by R. So, here N1 equal to refractive index of first medium and N2 is equal to refractive index of second medium. Okay, students. Then U is equal to object distance, V is equal to image distance, and R is equal to radius of curvature. And this is very important to you, that will ask your diagrams to write the curved surface formula and explain the terms in it. So make these notes very carefully, students. So once again I am reading you, N2 by V minus N1 by U is equal to N2 minus N1 by R. Here N1 is refractive index of first medium, N2 is refractive index of second medium, U equal to object distance, V is equal to image distance, R is equal to radius of curvature. Okay, by using this formula we can find some solutions to the problems. Okay, and curved surface formula in a case of plane surface. See, what is that? Curved surface formula in a case of plane surfaces. So here the radius of curvature value approaches infinity. So here we can, so in the plane surfaces radius of curvature approaches infinity value. Then at that time 1 by R equal to 0. Then the formula is N2 by V minus N1 by U is equal to R, because R value is infinity now. See, if you observe it, R value is infinity. Then here we get N2 by V minus N1 by U is equal to R. Then we translate the N1 by U term to the right side. Then what will happen? N2 by V is equal to N1 by U. Okay, students. This is the formula for plane surfaces. Okay. Then by using these formulas, How can we apply these formulas in our daily life examples? For example, we have taken here one example. A bird is flying vertically towards the surface of water in a pond with constant speed. There is a fish inside the water. Okay, if the fish is exactly vertically below the bird, then the bird will appear to the fish to be. Means a bird is flying vertically towards the surface of water. Vertically up towards the surface of water. Okay, here. Then at that time, there is a fish inside the water. If the fish is exactly vertically below the bird, then the bird will appear to the fish to be, see here, just like a image which is given in our textbooks also. First understand the problem. Okay, so here the bird is flying, so it is vertically up to the fish. Okay ma. Okay, then now we have to find it where the image of the bird appears to the fish, whether it is an actual image or a further image. Okay, whether it is moving in a slow direction or in a fast direction, we have to find it. Okay, so how the bird is appearing to the fish? So where the bird image appear to the fish? Let us see. Okay, here the bird is flying. Okay, here a fish is there inside it. On the surface of the water, both are there. See here, for both surfaces, here refractive index of N1 is equal to 1, means air, and refractive index of water is N2, that is N. Okay, now we can find the values, okay, by using the ray diagram. You can watch it. See here I have drawn a ray diagram. Just observe it. So when the bird is in actual position, which was given in the textbook also, so here when the bird is in actual position, at that time the light ray travels, okay, on the surface of the water and reaches the fish. So at that time the refracted ray is not going to deviate because it is in traveling. Okay, so another light ray which is taken as here, it has taken it further, and if you draw the normal, here again the refracted ray is towards the normal. Here I have taken two rays. So one is which is not going to deviate and another is this bending. If you extend the two rays in the upward direction, because here the refracted rays for the first and second ray are not going to meet at any point because they have so much of distance. Okay, so if you extend the rays in the upward direction, then at a point they meet here. See here I have shown you a point where the two rays are meet. So at that point only the fish appears the bird image, that is virtual image. Okay students, that distance is called as y, and where the actual position of the bird appear to the fish is x. Okay, so So in the first ray diagrams, they are not going to meet. So we have extended the light rays in the opposite direction, means in the upward direction. So at some point they meet. So at that point is a virtual image of the bird. So the actual position of the bird is not in the correct position. So the further means it is long. Okay, so the actual position is very small comparing to virtual image. That is n1 is equal to 1, n2 is equal to n. So here we are measuring the in opposite direction. That's why u is taken as minus x and v is taken as minus y. By substituting these values in the curved surface formula, we get the image, we get the answer. See here, it is a plane surface. Okay students. So here for plane surface, n2 by v is equal to n1 by u. Okay, so what is the value of v means minus y is equal to n1 by what is the value of u means minus x. So here n by y minus n2 means y, sorry, n2 means n, that is equal to n1 means 1 by x. By cross multiplication we get y is equal to nx. So here n is the refractive index of the two surfaces. Okay, like this we can solve the diagram. So here what is happening? The speed of the bird observed by the fish is greater than its actual speed. Okay, so here the speed of the bird observed by the fish is greater than its actual speed. So options A and C are correct. Okay, option A and C means further away than its actual position, we get it, and C is moving faster than its actual speed. So both A and C are correct. Okay students, maybe this problem will ask you for your examinations. Okay, so next problem is a transparent sphere of radius r and refractive index n is kept in air. So at what distance from the surface of the sphere should a point object be placed on the principal axis so as to form a real image at the same distance from the second surface of the sphere? So you can understand these terms by the diagram, okay, which is given in your textbooks. Here a transparent sphere has taken and its radius of curvature is taken as r. Okay ma, and the refractive index is n. So here what you have to find means at what distance from surface of the sphere should a point image. So here if you take here from the circle itself, so from the surface of the means pole, from the pole where we have to keep a point object, so that you can get the same distance image at the opposite side. So we have to find where we have to kept a point object so that the same distance has to be come to the image also. So we have to find where we have to keep the point object. So we have to take an as only left side portion of the sphere, means left side portion of the diagram. Okay students, now let us see here. So if you observe in the diagram, so for example we have taken here as point object here O. Okay, the distance from the point and P is x. Okay, now here the ray is traveling and hit the curved surface area of the sphere. Okay, So here after meeting the curved surface area, then again the ray is traveling parallel to the principal axis. Why the ray is traveling here parallel to the principal axis means, if you draw the normals, to both the refracted rays. Okay, so when the light ray is traveling from air means from rare medium, so you have to draw the normals from the radius of curvature. And if you draw the, just we have taken a assume that the image distance is maybe fall like this only, so at that place also you have draw the normal. So maybe by joining the two normals we get the ray parallel to the principal axis. So we have to know why the refracted ray is parallel to the principal axis means, when we draw the normals to the two rays, to the two assumed rays, so where the two rays are meeting by joining the line, that line is considered as parallel to the principal axis. Okay students? Okay, so here now we can enter the values of these in the formula. Okay, that is, what is the formula for curved surface? That is n2 by v minus n1 by u is equal to n2 minus n1 by r. Okay, here u is taken as minus x because that is the object distance is from pole to object. That's why we have taken as, according to sign conventions, we have taken as minus x. And v is taken as infinity because if you observe in the diagram, here we have taken only the left side portion of the rays. Sorry, left side portion of the diagram. So here, if it is traveling parallel to the principal axis, the ray meet at anywhere. Okay, the image may be at infinity. So we have taken here v value for infinity. Okay ma? Then n1 is equal to 1, that is in air, and n2 is equal to n. Okay, by substituting these values in the curved surface formula, we get like this. Okay, n by, that is n2 means n by v value infinity, minus n1 means 1 by u value minus x is equal to n2 means n minus n1 means 1 by r. So n by infinity value becomes 0. So minus into minus plus, that is equal to 1 by x is equal to n minus 1 by r. Okay, then we get x is equal to r by n minus 1. Okay students, r by n minus 1. So this is the formula, that is to find the distance object from the first curved surface. So by substituting values for this formula, in this formula, we get the point object where we have to keep it. Okay, we can get the point object distance by keeping the values for this formula. Okay ma, this is the formula for you. So we can find object distance from the first surface of the sphere by this formula, that is x is equal to r by n minus 1. So next problem. So a transparent glass sphere has a small opaque dot as its center. A transparent glass sphere has a small opaque dot at its center. Does the apparent position of the dot appear to be the same as its actual position when observed from outside? So I will explain to this by using the pictures. Okay, here a transparent glass is there. Now I have kept a dot at its center. Okay ma, here when the light ray is traveling from the denser medium to rarer medium, means from the glass sphere to air. Okay, again one more ray is traveling in the opposite way, in the other way. So here the two rays are not going to meet at any point. If you extend it, it may be meet at one point if you extend the refracted rays in the backward direction. Okay, if you extend the rays in the backward direction, maybe it may be meet. So first the two light rays are coming from the center, there is no deviation. So these two light rays are not going to meet. We can't get a real image also. So if we extend these two light rays backwards, again they are not going to meet at same point. Maybe the same point they will be meet. Okay, so by substituting values here, see here, if you take an as u is equal to minus or means, according to sign conventions, the object distance is measured from pole to object, but the ray is coming from object to pole. That's why we have taken as minus r. By substituting this value in the formula, that is curved surface formula, we get n2 by v minus n1 by u is equal to n2 minus n1 by r. Okay ma? That is n2 means it is one value because the light ray is entering from denser medium to rarer medium. Okay, so for that n2, denser means n1, air means n2. So n2 is taken as air, no, that is value 1, and n1 is denser medium, that is taken as n. So that 1 by, there is 1 by v minus n1 means n by, here I have kept as r. So you have taken as r, keep it, correct it, okay ma, r is equal to n2 means 1 minus n by, here r you have taken as minus r. Okay, now 1 by v plus 1 by, n by r, minus into minus plus becomes, and n by r is equal to 1 by my, so I have separated the r to both the terms, that is 1 by minus r, minus into minus plus n by r. Okay students, that is by cancelling the n by r terms on both sides, we get 1 by v is equal to 1 by minus r. So by we can get, that is v is equal to minus r. So we get u is equal to minus r, v is equal to minus r. So by extending the rays also we get the same point, no, that's why. Okay, image distance and object distance are equal for this problem. Okay, so apparent position of dot is same as its actual position. Okay students, so this is the video of this lesson. So maybe if you got any doubts, you can watch the video again and again so that you can clear your doubts. Okay ma? Now I am concluding this video, this online class, by giving worksheet to you. Okay, so these are the questions to you which are related to this class. You can answer it very easily. Okay, so complete the worksheet in your notebooks. Okay students. Okay, thank you.